So with this video clip, I'll try to explain how you can figure out how much can a boat carry. First we need to find the area of the cross-sectional shape of the canoe or boat or whatever we're trying to measure. I have some containers in the class that are a lot of them are shaped like this. And you try to figure out volume, you need to figure out the area of a cross-section first. So like on one side of a rectangle, I might have a width of 6 at the bottom and a width of 10 at the top. Usually to figure out the area, I multiply the height times the width, but I'm not sure which width to use. There's two of them really. So what we can do is we could say, well, let's take the average. How do you find the average? You add your 10 plus your 6 and you get 16. There's two of those, so you divide by 2, and that tells us that the average width is 8. So if we multiply our height of 10 times our average width of 8, that tells me that the area of that shape is 80 square centimeters. And I would multiply by how long it is the other direction to find the volume. If something has a round feature, then we need to find the area of a circle, and then multiply that by how tall the can is, or whatever object it is we're trying to find the volume of. So let's look at the top of the can. From the center to the edge is 4 centimeters. The area of a circle is equal to pi times the radius squared. So the area is equal to 3. Well, pi is not exactly 3, but that's probably close enough for what we're doing. Times the radius squared, which is 4 squared. So the area equals 3 times 16. So the area of the top of the can would be 48 square centimeters. Well, if it's 15 centimeters high, then we take our 48 square centimeters times 15 centimeters. 5 times 8 is 40. 5 times 4 is 20. Bring at plus 4 is 24. Move over 1. 1 times 8. 1 times 4. Add them up. 12. 4 plus 8 is 12. Carry the 1. 4 plus 2 is 6. Plus 1 is 7. So 720 cubic centimeters. That means if I had 720 cubes that were all 1 centimeter by 1 centimeter, that's how much liquid could fit inside that can. Of course, if they're square, they don't fit inside of a round can very well, but if you figured out that much water, that much liquid, you could pour it into the can and it could fill in just fine. Each cubic centimeter can hold 1 gram of water, so a toy boat that has a volume of 100 cubic centimeters can float with 100 grams loaded on it. So if we can figure out the volume of that boat to be 100 cubic centimeters, then I could put 100 grams in it and it would almost sink, but not quite. So your task is to measure the dimensions of a container at your desk. Come get one from me when you get to this. And you can take it to your desk and measure it. Calculate the volume. Tell me how many grams your container can hold. And then, just try to be as close as you can so you can get it to almost sink but not quite. And then we'll test it out. So you'll ask me for the number of grams that you think the volume in cubic centimeters is, and I'll give you that many grams. We'll put them in your container, and then I'll put it in the water and see if it barely floats to check out, see if you calculated the volume correctly. It's just a fun way to check our work.